Okay, in our last lesson, we just learned about the properties of polygons, and today we're going to talk about a specific polygon, which is a quadrilateral, and a specific quadrilateral called the parallelogram. So go ahead and title your note properties of parallelograms. Parallelograms are a special type of quadrilateral, or a quadrilateral, with four sides, remember. With both pairs of opposite sides parallelograms are quadrilaterals with both pairs of opposite sides that are parallel. So this means that they have opposite sides, and these opposite sides are parallel. So let me draw you an example. Say like you have parallelogram P, Q, R, and S. To be a parallelogram, these two sides which are opposite of each other must be parallel, and these two sides which are opposite each other must be parallel. And in order to show that, we're going to do these little arrow marks, and these arrow marks indicate that they're parallel to each other. So PQ is parallel to SR, PS with the double arrow is parallel to QR. So I'm going to write this out for you to see. PQ is parallel to SR, and QR is parallel to PS. And the way that we name parallelograms, or the way we symbolize parallelograms, is by just this little symbol right here that looks like a parallelogram. We call it parallelogram PQRS, or this is the same thing as saying parallelogram PQRS. Now, parallelograms are cool because there's a couple of things that apply to them. So we're going to go through these different theorems, and we're going to do examples using the theorems that we've learned. So let's go ahead and write down theorem number 1 about parallelograms. The first theorem is this. If a quadrilateral, or a four-sided polygon, is a parallelogram, then its opposite sides are congruent. So not only are these sides parallel to each other, we also find out now that PQ and SR are congruent to each other, and PS and QR are congruent to each other. Or, in this example, this is P, Q, R, and S, and PQ is parallel to RS, and QR is parallel to PS. We can also go ahead and do these little tick marks right here to show that they're congruent. The opposite sides are also congruent to each other. So in parallelogram PQRS, PQ is congruent to RS, and QR is congruent to PS. So, an example. We have a parallelogram, and yes, this could be drawn better, but it's not. J, H, G, F. And we're told it's a parallelogram, and it's indicated like that by these little arrow marks saying that JF is parallel to HG, and JH is also parallel to FG. And we're told that HG is equal to 3 and FG is equal to 5, and we're told to find the two missing sides. Well, we know, because this is a parallelogram, that JH is congruent to FG, excuse me. So since since we don't know JH, I'm just going to go ahead and write that down. But we know what FG is, and we know that FG is equal to 5. So therefore JH is equal to 5. And I'm going to go ahead and label that up there. And we also know that HG, since they're opposite, is congruent to JF. And we know that HG is equal to 3, so therefore JF is equal to 3. So therefore JF is equal to 3. Now we can go ahead and label that 3.